Hey guys, so we are going to finish up this week's section with tables and graphs. A lot of wording involved, but fairly simple. You've seen a lot of this before. So let's get started. So the ACT uses different methods of representing data. Again, some that you're already familiar with, such as tables and bar graphs. However, some can show up that you probably haven't seen, or it's been a long time, or you've seen it very few times in your life, such as histograms, piecewise graphs, and circle graphs. They're not really difficult to interpret, but it's helpful to keep in mind that the test maker often includes more information than you actually need. It's also important to consider what the question asks for, so you find only the information that you need. They're going to give you a lot of extra stuff that you don't need. So it's important to read and scratch out information that is irrelevant or just extra information. So the first we're going to look at is a histogram that's right here. It looks like a bar chart. So if you've seen bar charts before, it's very similar. However, histograms show how many times a certain value shows up in a number range. So the numbers on the x-axis provide boundaries for each bar's range. So this is from 15 to 20 versus where a bar graph, you're only looking at the 15 section. So you're not looking at, in a histogram, you're looking at a range, which is a bar graph, you're not. Next thing is a piecewise function or piecewise graph. And so the domain is your set of x values. So this is going back to your algebra and algebra 2. So your domain is always your x values. And piecewise can be similar or vastly different. All of the pieces should be horizontal segments of the same length that jump y coordinates. And all that's saying is that it's typically always connected. So here everything is connected. It just jumps up and down. But my domain is still pretty much all real numbers. It's just I'm jumping around. Remember, if it's open circles, that means not included. Closed circles are included. So we can look at the solution for this piecewise function that when our x values are less than or equal to -2, so we're looking at this section. So we're looking where x is -2, all these x values, so towards negative infinity. All of this, my solution is just 1. Y equals 1 all the way through. Then I can see I've got this parabola right here. So this parabola is true when x is -2 to when x is +3. So this is my next set. And then I have this one solution right here where x equals 3. And then I also have a final solution from x equals 3 all the way to positive infinity. And this is going back to our inequality section. Just remember, again, if it's an open circle, it's not included. If it is a closed circle, it's included. In order for it to be a function, it can only have one solution, which is why right here where x is 3, it's circled in, it's closed, and both of these are open. If this one were to also be closed, this would no longer be a function because we would have more than one x value. Lastly, are circle graphs. They're also called pie graphs because they look like a pie. And it represents data as parts of a circle where relative percentages dictate the portions of the circle. So when displaying data in a circle graph, you find the measure of the angle and multiply each percentage by 360. So this is how much percent of 360 degrees we have. So for example, a sector that represents 35% of the data should have a central angle that measures approximately 126 degrees. So this is almost 35%. Well, it's 34.25. So we can just 34.25 times 360. So this It's percent. Let's put in decimal, my bad. 3425 times 360. And you get 123.3 degrees for this piece. When you're done, the percentages should add up to equal 100%, and the angle measure should sum up to 360 degrees. So it's just different ways of looking at these. Some extra information. When presented with a question that uses a graph or table to present information, first inspect the format of the graph or table. What kind of graph or table is it? What information is presented on each axis or over here on the side? And what other information are you going to need in order to answer the question? Find the information you need from the table or graph, and then use the information for any calculation the question might require, such as taking the average, finding the median, or determining the expected value. Remember, average, you add all and divide by total number. So if you have a series of numbers, you add up each of those numbers and divide it by how many numbers total there are. Median, you order least to greatest and find middle number. And then determining the expected value, which is what they're asking for. So we're going to look at two questions. These are ACT prep questions. Chris lives in Omaha, Nebraska. He works in regional sales and has to travel throughout the week to meet with clients. The graph shows the distance that Chris's car is away from his home over a period of time in a given week. Which of the following situation best fits the information recorded? So some of the tips that we've talked about so far is reading what's here. So these are the days of the week. This is the distance from home. So home right here is 0. This is where home is. And we're trying to find what best fits the information. So Chris leaves one of his clients, drives to another client, stays there a few days, and then returns home. That pretty much makes sense. I leave one client. I'm not home. I'm not leaving home. I'm leaving somebody's house. I go to another client. I'm going to stay there for a while and then return home. So that looks like it's probably my answer, but I am going to go back and read everything and make sure, because it says best fit, meaning I'm trying to find which of these makes the most sense. Meaning, again, I need to read each one. Chris leaves one of his clients, drives to another client's, and then drives back home. Kind of, but there's this period where I'm staying somewhere. So this one doesn't quite make sense. A makes more sense. Chris leaves one of his clients, drives back home. He does not go home instantly, so that does not make sense. Chris leaves home. He's not leaving home. He's leaving somewhere 200 miles away. Chris leaves home. Again, does not work, so A makes the most sense, and A is the answer. So anytime it talks about best fit, you do need to read each question or each answer choice and find which best fits what the graph is talking about. Next one. A probability and statistics class conducted a die rolling experiment. Each trial of the experiment consisted of rolling a single fair 6-sided die 6 times. So we're rolling this 6 times and counting the number of threes that resulted from each roll. The class recorded the results for 100 trials in the graph. And approximately what percent of trials did the class roll threes more than 2 times? So again, look at your sides. This is number of threes per 6 rolls. This is number of times rolled. So we want to know percent of trials did the class roll threes more than 2 times. So this is twice. This is 2 times or less. This is more than 2 times. So we're only focused on this area. So we can see here, and this is where I would mark all over my graph for questions like this. I can see, if I draw this over, It's about 10. I did that really poorly. But my best guess is I know that it's more than 10 because this looks to be about 10. But I wouldn't say much more. So the answer would be D. The other way you can do it is look at what 2 times is. And I have 35 and 50 gives me 85. This is what I don't want. So 100 minus 85 gives me 15%. Or you can look kind of best guesstimate what these look like. I know it's more than 10, but not much because these both look like they're less than 5. So my best guess is that it's going to be 15%. So none of these really required a lot of math. It's just using your knowledge on what the question's asking and using that graph to answer your question. So now you guys have some practice straight from the ACT prep book. Let me know if you have any questions.